We are with Unit 6, Lesson 6, the slope of a fitted line. So today what we're going to look at is working with slope of a fitted line. Remember that a fitted line is also called the trend line, but it's going to be something that helps us to work out information about how data change over a given time. So here's a situation where we have a line that's going through 3 points. That line doesn't actually touch the 3 points, but it is fit to the data here to represent a center point. I'm going to compare two different lines, one that's really close. So this line is really close to these 2 points. So I'll find the slope of these 2 points, and then I'll take the slope of -4, -6, and 8.3. I'm not going to pay attention to the slope of 5.2 because that line is so far out there, it really wouldn't make any kind of sense. This first one, what we're looking at is 2 minus -6 for our change in y, and then 5 minus -4 for our change in x, giving us a slope of 8/9. Now, what we could say with this is that that slope is just under the actual slope. When you go to look at this and you find the actual line, we see that it's just under that slope. It's not quite as steep as 8/9, so it's just less than 8/9. If I compare that to this other line, we can see that it's a little bit further off, which tells us that this slope would not be a better slope to use, but we can see that it's not a big distance off. We see 3 minus -6 and 8 minus -4, giving us 9/12. We see that that slope is not as dramatic, but this would be a poor estimate because it is significantly different than the other one. This one would be a good estimate for those values. So those are some things to think about as we look at these pieces, and good information to pay attention to when we're talking about the slope, using a couple of points that are really close to the trend line or to that fitted line. For the next setup, what we're doing is we're going to look at each scatter plot and decide if there's an association between the two variables and describe the situation using one of these sentences. So we have 3 sentence starters. We're going to look at one that says, for these data, as blank increases, blank tends to increase. So we're looking at the two variables, and we're going to look at this from the term, or from the value of, usually we're going to say x coordinate, y coordinate. Okay, because we have the independent followed by the dependent. We would always talk about the dependent second because this one is going to change as a result of this one. So another one, we can see that the data increases while the other tends to decrease, and we can see that the data do not appear to be related at all. When we look at the first example, we see mileage and price. What we could do with this one for mileage and price, I see that as the mileage is increasing, that the price is decreasing. There tends to be a trend where the data decrease over a certain amount of the value of x, and so we can say as mileage, I spelled that wrong. As mileage increases, price tends to decrease. So just interpreting the data, that makes sense that cars with higher mileage tend to cost less. For the next one, talking about weight in carats and price in dollars, I would assume that this is probably the one about the diamonds again. When we talk about that, we can see that there's a clear trend or a clear pattern here, that as the weight of the diamond or the weight of the gem is increasing, we see a price also increase. So we could say as weight in carats increases, the price tends to increase. Which again makes sense. Okay. All right, one more. Here's one talking about high temperature and energy consumed in kWh. This is called kilowatt hours. Kilowatt hours is how we measure energy because that's how electrical works. With this one, it might be tempted to say there's no association. But when we think about trying to set this up and look at it, I think it's pretty clear that when I set my ruler across here, you can see a pretty clear pattern that all these data start at a fairly low point, 75 degrees, and then the temperature increases, and we see a pretty clear pattern that the energy is consumed. If we really just eliminate these 3 points, we can really look at these other pieces and see, yeah, there's definitely a pattern here that as the high temperature increases, the amount of energy used is also going to increase. These pieces over here probably tend to be somebody that said, you know what, I'm really cold, so I'm going to turn the heater on at 76 degrees, 77 degrees, maybe this is Arizona, you know, that kind of thing. But we can say as high temperature increases, energy consumed increases. I guess we should say tends to increase. All right, so that's just the big idea of this, is that we read the data to be able to understand what's going on. You may assume that you need to use each sentence exactly one time in this activity, but we're actually going to use them in the way that it's acceptable to use that sentence more than once, because that's what it is. We have to read the data for what it is to be able to understand how data changes and how the representations on these scatter plots change. So there might be some surprises in there. You might notice some associations between the high temperature and energy consumed is like, this is more of a variable than other situations. This is what we would call a weaker correlation than the other graphs. The other ones are a little bit more direct. They're a little bit easier. They're a little bit easier to tell that there is certainly a negative correlation here and a positive correlation here. All right. The next thing that we're going to go for is this says interpreting slopes. And for each of these situations, there's a linear model that's been given to us. And so we are going to use that linear model to be able to actually answer the questions. Earlier, we looked at the price of cars related to the mileage for those used cars. We saw that these used cars, the price tends to decrease as the mileage increases. So we're going to be looking at this scatter plot. Here's the vehicle scatter plot. And this is the one that we're going to be using for one of these situations. And for this situation, we need to, and for each of these situations, we're going to figure out the slope of the line in the scatter plot. We're going to write its meaning of the slope in that situation. So we have this one right here. Y is equal to 5,520 and 619 thousandths minus, or times X minus 1,091 and 393 thousandths. We have another one that shows a decrease, which is going to go with this one right here. Not a very good job on printing these. I apologize. Here's our equation. Y equals 520.619 minus, and I think I just told you a little bit ago that this was the vehicle and this one is not the vehicle. This one is clearly the diamonds because the vehicle price is one that's going to drop. Sorry, I'm not prepared on this one as well. I didn't realize this before I started. So as we look at the diamonds, what we could say that with this diamond is we're talking about the slope. We know the slope is equal to 5,520 and 619 thousandths. And what we're after with that is we need to interpret that slope. That slope, we see it right here as the coefficient of X. And what we could say with that is that the average price per carat of weight is $5,520.62 or 619 cents. And I know it might seem silly that we're going to take it out to the thousandths, but the thousandths actually really matters big in something like this. So that's all we're doing with that. We talked about the weight of a vehicle and the fuel efficiency. We identify the slope again as the coefficient of X, and that slope is negative 11 thousandths. What does that mean? Well, it means that as the weight increases for each kilogram of vehicle weight, the fuel efficiency decreases by 11 thousandths miles per gallon. There you go. So just really looking at it and saying that I have the fuel efficiency over the weight. So as the weight increases, the fuel efficiency decreases. And then for our last one, we look at this piece talking about high temperature and energy, 59 hundredths times X. I'll show this back on here in just a second. Here's our equation for the final one. That high temperature, what we see with this is we had a fit line or a fitted line that was placed in here by a computer. And so this would be the best line of fit based on all the data. And when this comes into play, what we're looking at is we do see that slow increase. In fact, what we're seeing with this is as the high temperatures increase, we would talk about here as, or for every degree of temperature increase, we see 59 hundredths kilowatt hours used. So that would be our piece that we're recognizing that slope again, that slope is going to increase over a certain amount over a certain amount of time. All right. That's kind of the biggest piece of this. Going back to these with our equations, what we're after with this, the equation for these lines that we're using, and when we're talking about these slopes and the meaning of the slopes, is related just simply to the approximation of these values. So when we look at this, this is not the actual exact slope of the data. It can't be when we're talking about the weight and the price because the values vary so much. We understand that the weight of that diamond, or the weight of the diamonds as it increases by that 1 carat, the model predicts that the price will increase by that much each time. We could round that up to 55.21 if you wanted to, but it's really not necessary. We also see that the prediction is that as the weight of the car increases by every kilo, that the model predicts that we're going to decrease by a certain amount of miles per gallon. And then likewise with this, it's just a prediction for the path. It's what sets our energy rates as far as how we sell or as how we buy those values. So I think the easiest way to find the slope for each of these situations is simply to look at the equation and look for the value that it says next to the X, that coefficient of X. Do they make sense in the context? Absolutely. All of the context for these, it makes total sense that we're going to see some kind of an increase or a decrease because of what it was that was given in the situation, where we see that the slopes in those values could increase or decrease. For this next one, are you ready for more? I don't want to spend a lot of time on this one, but what is the value of the slope and what does it mean? Well, in here, we're going to look back to the equation. The scatter plot shows the weight and fuel efficiency data that was used earlier in the lesson. We see that the slope is written just a little bit different than what we saw earlier, where we saw it to the thousandths. This one went out to the 10 thousandths. And what does it mean? Well, it means that as a vehicle increases in weight, the fuel efficiency is going to drop. So what's the other number in the equation represent right here? Well, that would be our y-intercept. It's going to be the value of the y-coordinate when the x is 0. So in other words, that y-intercept of the graph, it means that a car that weighs nothing, 0 kilograms, would have a fuel efficiency of about 41 miles per gallon, which seems kind of silly as we look at that, but that's how the data read out. And that's why you don't see any kind of data over here on the actual y-axis, because we don't have vehicles that weigh nothing. So the last thing that I want to get to is this positive or negative. And it's just really understanding what we mean by positive associations and negative associations when we talk about a positive slope, negative slope, anything like that. And I think we've kind of talked about it enough that we can look at these and recognize and say, you know, what would the linear model represent with these ones? If we were to talk about this linear model, if I were to put a trend line in there, I could certainly see a negative association. Where we see that the data, as the X increases, the Y decreases. With B, I can see there's probably a positive association here. It's more of like a somewhat weak because the data are pretty spread out, but there's still a positive association. Letter C, we can see that the data trend is that it's decreasing over time. And so we could call this one again another negative association. Letter D, we would actually say that a linear model doesn't fit really well. Notice how far these data are scattered out. There isn't really any kind of clear pattern to indicate which way we're going. And so with this one, we would say, what did they say up here? Slope of 0. We're not even going to use a slope of 0 right here. We're going to say data do not appear to be associated. Now here's the part where you get upset with me, where you could just simply say no correlation. But you have to understand what that idea means. No correlation means that the data don't appear to be associated with each other. The final one, it does appear to have a nice positive trend to it, but we do see this one down here, which is an outlier. So we could say that there's a positive trend with an outlier. All right. As we look at this next question, which of these scatter plots show evidence of a positive association between the variables, negative association, which do not appear to show an association? We just already got to that. Positive is going to be B and E. Negative is going to be A and C, and then no association. What we're looking like this last part doesn't appear to show an association is going to be letter D. Okay, I hope that part was pretty straightforward, pretty simple by now, because that's the end of our lesson. When we look at this scatter plot again, one we've seen before, as noted earlier before, we can see that a scatter plot talking about taller dogs tend to weigh more than shorter dogs. We can definitely see that there's some kind of a positive association. As the height increases, the weight increases. Seems like a pretty logical thing to say. When we go ahead and put a fitted line to the data, we see that we can come up with an average slope, and that average slope says that for the height of the dog, meaning that value for the height of the dog is H and the weight of the dog is W, we can see that the slope is 4 27/100, which tells us for every 1 inch that the dog increases in height, the weight is predicted to increase by 4 27/100 pounds. I would really point that piece out. It says the weight is predicted to get that piece. We have to understand that these trend lines, scatter plots, there's no way to get an exact value, but there is a way to predict values for future occurrence. So I think that's enough for this video. Thanks for hanging in there. Let me know how I can help you out, and I hope you have a great day.